Assalamualaikum and hi everyone. My name is Zida Kamalia and I'll be representing Group 10 for our presentation on the production of cumene from benzene and propylene. It is my pleasure to welcome especially Ms. Basira and everyone that is watching right now. And I'm quite sure that some of you guys might be wondering about what exactly is cumene and how it is produced and what is it used for. But before we dive into the details, let me briefly introduce my team. So this is me, Zida Kamalia, or you can call me Zida. And this is Yongji Lee, or you can call her Nicole. And this is Siva Chini, or you can call her Siva. And this is the overall overview of our process, starting with the introduction, process description, diagram, details, mass balance equation, assumed data, and conclusion. And as you can see on the screen is a PFD, also known as process flow diagram of our whole process that I'll be explaining to you guys later in details. So what is cumene? Cumene is an organic compound that contains a benzene ring with an isopropyl substituent. It is a constituent of crude oil and refined fuels. Also, it is a flammable colorless liquid that has a boiling point of 152 degrees C. Nearly all the cumene that is produced as a pure compound on an industrial scale is converted to cumene hydroperoxide, which is an intermediate in the synthesis of other industrially important chemicals, primarily phenol and acetone, known as the cumene process. So basically, cumene is an organic compound, and that is why the formula that you can see on the screen here is like a bit complex, is because it is a chemical compound that consists of benzene and propylene, and it is an important chemical compound because it is used to make another thing, for instance like phenol and acetone. Okay, so when producing phenol or acetone, we have to add this cumene to produce plastics, resins, and adhesive, as you can see here. And also it is also used as a solvent in paints and coatings. Cumene derivatives can be found in products like fuel additives, antioxidants for materials like rubber, and even in the fragrance and flavor industry for perfumes and flavorings. So we can see here that cumene plays a vital role in creating various everyday items and industrial materials. Moving on to the chemical reaction that occur in this process, divided to Moving on to the chemical reaction that occur in this process, and it is divided to two reaction. The first one is a primary reaction or the main reaction, and it produces desired product. Meanwhile, side reaction or secondary reaction produce an undesired product, which is DIPB. So for the primary reaction, propylene reacts with benzene, producing cumene. Meanwhile, side reaction, propylene reacts with cumene itself and producing diisopropylbenzene. And the stoichiometry equation for this chemical reaction: for primary reaction, 1 kmol of benzene equals to 1 kmol of propylene equals to 1 kmol of cumene. Meanwhile, for side reaction, 1 kmol of benzene equals to 2 kmol of propylene equals to 1 kmol of cumene. Moving on to the process description. So for the whole process is divided to 3 sections. The first one is storage and pumping section. The second one is preheating and vaporization section, and the last one is separation and purification section. And this is the whole process, or we call it as PFD. Alright, so for the process, starting with the raw materials here. So this is the storage and pumping section. This is the vaporization and preheating section, and this is the separation and purification section here. So starting with the first section, okay, the raw materials, which are benzene and propylene, each stored in the 500 milliton capacity tanks. They are pumped to the production unit by centrifugal pumps. Benzene is mixed with recycled benzene in a feed vessel. Okay, and next benzene is pumped into a vaporizer at 25 atm pressure, vaporized at 243 degrees C, and mixed with the propylene at the same conditions, okay, the same pressure and the same temperature. So benzene will, as I mentioned earlier, benzene will go through the feed vessel to mix with the recycled benzene, and only then will go to the vaporizer to mix with the propylene. And then the vapor mixture, including cumene, DPIBB, unreacted benzene, propylene and propane. Next, benzene is pumped into a vaporizer at 25 atm pressure and 243 degrees C, and mixed with the propylene at the same condition. And then the mixture goes through a fired superheater to reach a reaction temperature of 350 degrees C. So the temperature rises as it goes here. And then the vapor mixture, including cumene, PDIPB, unreacted benzene, propylene and propane, enters a reactor cube packed with a solid phosphoric acid catalyst. The reaction's heat is removed by pressurized water used for steam production, and then the effluent at 350 degrees C becomes the heating medium for vaporizing benzene. Okay, so the effluent will go to the vaporizing the benzene vaporizer to become the heating medium. After that, it will be cooled down to 40 degrees Celsius in a water cooler, and then after that it will go to separator. Propylene and propane are separated from the liquid mixture. Fuel gas is used to fuel the furnace. The liquid mixture goes to a benzene distillation column at 1 atm pressure, yielding 98.1% benzene as distillate for recycling. And then the bottom liquid goes to a cumene distillation column. Okay, so this is the benzene distillation column and this is cumene distillation column. Okay, and then after it goes to the cumene distillation column, resulting in 99.9% pure cumene as distillate and pure PDIPB at the bottom. The heat from PDIPB is used to preheat the benzene column field. And yep, and we're done. Utilities like cooling water, electricity, steam from the boiler, and pneumatic air are supplied from the utility section. And this captures the main steps in the cumene production process. So this is the mass and balance equation. The law of conservation of mass states that the total mass of various components involved remains constant during a unit process. Thus, any unit process rate of mass input equals to rate of mass output plus rate of mass accumulation. For steady-state operation where accumulation is constant, rate of mass input equals to rate of mass output. So this is the assumed data. Conversion is 99% of propylene, product molar selectivity. Cumene to PDIPB is 31 to 1. Propylene feed is 95% pure and rest of propane. Benzene is about more than 99.9% purity. Molar feed ratio of benzene to propylene is 2 to 1. Top product of benzene column is 98. Top product of benzene column is 98.1% benzene and 1.9% cumene. Meanwhile, top product of cumene separation column is 99.9% mole of cumene, Modern product of cumene separation column is 100 mol % PDIPB. Let B. Propylene is the Thai substance that does not participate in the reaction, used as fuels. So the basis of this is 300 tons a day equals to 300 tons per 24 per hour equals to 12.5 tons per hour equals to 12,500 kg per hour of cumene equals to 104 kmol per hour of cumene. And this is the stoichiometry equation I've mentioned earlier. Okay, propylene used for the cumene and DIPB. So for cumene, propylene required is 104 kmol per hour. Selectivity is 31 to 2:1 of cumene to DIPB, i.e. catalyze converts propylene and benzene to the ratio of 31 moles of cumene and 1 moles DIPB. Conversion of propylene is 99%. Let X kmol of DIPB form. Then cumene form is 31x equals to 104x equals to 3.35. DIPB form is 3.35 kmol per hour. So this is the propylene balance, and this is the given, and this is the propane present, this is the benzene balance, and this is the whole material balance equation. So this is the material balance equation for big vessel, this is for the balance around reactor, this is for the separator, benzene distillation column, benzene balance, cumene distillation column, and the balance of cumene, which is 3.35 kmol. And this is the overall plant materials balance that is simplified. Okay, so this is the input and this is the output and this is the molecular weight. And for the yield, as 1 mole of cumene is produced from 1 mole of propylene, the stoichiometry factor is 1. Moles of cumene produced equals to 104.60 kmol. Stoichiometric factor is 1 in the equation. Moles of reactant fat is 110.88 kmol. So the yield of cumene based on the propylene. So the formula is yield equals to moles of product produced times stoichiometric factor over moles of reactant back to the process. So this over this equals to 93.93% yield. So the conclusion, in summary, the cumene production process turns benzene and propylene into valuable products. Store the benzene and propane, mix them, then use heat exchangers and a heater to vaporize the mixture. The reactor with the special catalyst ensures a good conversion of propylene into cumene and diisopropylbenzene. And then separate and purify the products, recycling the benzene and obtaining pure cumene and DIPB. Distillation columns play a key role in achieving high purity. The material balance calculation confirmed that we are getting a lot of cumene from the propylene we put in. The whole process is well designed, making efficient use of utilities like cooling water, electricity, steam, and air. It's a good example of how chemistry and engineering principles can come together to create valuable industrial to process. And this is the reactions of cumene production that we have talked about. And yeah, our cumene production project was deep dive into turning benzene and propylene into a useful product. The project not only expanded our knowledge of chemical engineering but also showed how these concepts are applied in the real world. And our teamwork, communication skill, commitment to excellence were key to the project's success. In a nutshell, our cumene project highlights the blend of theory and practice, providing valuable insights into chemical processes and their broader application. And that's all from us. Thank you.